Right, let us continue our discussion on rates of reaction and factors that affect rates of reaction. And this time we're going to talk about how catalyst affects rates of reactions. So catalyst, you've probably heard lots of examples of it in real life. Catalysts are basically substances that usually help increase the rate of reaction. And they do this by providing another pathway for chemical reactions to be more successful by lowering the activation energy. All right? Think of catalysts as your Waze app that you have when you drive, and Waze app will help you divert yourself away from traffic jams, find shortcuts to get to your destination at a faster time. And so this is kind of like what that is. You know, they allow us to find shortcuts. And it all has to do with the ability for the catalyst to kind of bond to the reactants as it becomes radicals and form a pathway or a mechanical pathway that is of a lower energy state, requiring a lower activation energy state in order to overcome that. And so the products are made. Now, an important part about catalysts is that theoretically they're not used or exhausted in the chemical reactions, and theoretically they will not affect the amount of products that is made. All right. All it does is that it allows us to make those products at a much faster rate. And so catalysts also theoretically are reusable, and once they get used up, once they get used in the chemical reaction, they will usually revert back to its original state. All right. The physical appearance may change, however, the chemical properties won't. Okay, so that's an important part that you got to recognize about catalysts. And so, in order to do that, and whatever they teach you in school is that they lower the activation energy. Right. So you have here you have an original energy profile of an endothermic reaction with a very high activation energy. So this activation energy is quite high. So here is the energy potential of the reactants, and here is the energy of the products. So, and in order for reactants to make products, you have to overcome this big bump, this big activation energy barrier. And what catalysts do is to find an alternative pathway. And so the alternative pathway may say that, okay, the activation energy is this much. Okay? So you lower the activation energy from here to here, to here, to here. So that is an improvement from here to here, to here to here. So this requires less energy to overcome, right? And so collisions involving catalysts may help to make products more readily because of this lower activation energy. Other instances where activation energy is helpful is, of course, is endothermic reactions with high activation energy. But other instances where activation energy can be useful is slightly exothermic reactions. Okay, with high activation energy. So let's say you have an energy level of the reactants here, and you have a high activation energy. Let's go higher, so we can, and it's slightly exothermic. Okay, so this is a this reaction has a pretty high activation energy barrier, and so catalysts can provide an alternative pathway where the activation energy is quite low, and you don't, like kicking a soccer ball. You know, here you have to use a lot of force to kick a soccer ball to overcome the heel. Here, you use less strength to kick a soccer ball, and your soccer ball will go over there. So think of that catalyst being able to enable us to create products. Okay, Um, what about reactions that are low activation energy and extremely exothermic? Well, I guess you don't really need catalyst here because this reaction most likely may be spontaneous. Okay, so in this instance, you don't really need a catalyst. So people use catalysts in the industry for all kinds of processes, right? We use iron in the Haber process, which is something that we'll talk about later. Our cars has palladium as catalyst to kind of change nitrous oxides to and carbon monoxide to carbon dioxide and gaseous emissions that are, let's say, safer for the environment. So I've already provided examples of catalysts, and these catalysts were transition metals. All right, transition metals. Transition metals are good catalysts because of the properties of its electron shell in the f orbitals. I know I did not talk about f orbitals with you, but that's a whole different story. And other examples of catalysts is enzymes. And you know that our bodies are not very hot. You know, it's just around, I guess, body temperature, which is about 20 over degrees. I'm not a biologist, I can't remember those facts. And so we don't have a lot of pressure, we don't have a lot of temperature in here to allow chemical reactions or biochemical reactions to occur in our bodies. So that's why enzymes provides attractive pathway for lots of our respiration reactions to occur. So, all right. So that's the effects of catalysts on rates.